Finally, joint variation. So joint variation combines direct and inverse variation. So here's an example. X varies directly as the square of y. So let's just start writing that down. X varies directly as the square of y. And inversely is a cube of z. Inversely means that term goes on the bottom. And inversely is a cube of z. So let's go through that again. All we did was translate this phrase by phrase. X varies directly as the square of y would look like this. X varies directly as the square of y. And then inversely as the cube root, the cube root of z, sorry. I thought it was the cube of z, it's the cube root of z. So really we need to change this to the cube root of z. And inversely means it goes in the denominator as the cube root of z. So it's just a translation of exactly what you read remaining calm. And again, even with joint variation, we're going to be given all the numbers we need to be able to solve for k. That means we're going to be told an x, a y, and a z. Here's our x, here's our y, here's our z. All right, so we're going to plug those in and solve for k. If x is 6, when y is 2, so 2 squared would be 4. And z is 8, so the cube root of 8, that's just equal to 2. So far we have 6 is equal to 4k over 2. 6 is equal to 2k. Dividing both sides by 2, k is equal to 3. All we do in the next step is replace k with 3. So that gives us this formula, x is equal to 3 y squared over the cube root of z. And now we're going to be asked a question. Find x when y is 1 and z is 27. Find x when y is 1, so 3 times 1 squared is 3, and z is 27 over the cube root of 27. And the cube root of 27 is 3, so x is equal to 3 over 3, or in other words, 1. So these are pretty easy once you see the pattern. One more example. Y varies jointly as x and the square of z. Y varies jointly as x and the square of z. Notice it didn't say inverse anywhere, so that's why we didn't put anything in the denominator. All right, next sentence is going to give us everything we need to solve for k. So the next piece should have a y, an x, and a z. When x is 2, and z is 4, then y is 144. So let's put that in. 144 is equal to 2 times 4 squared, which is 16, times k. Or in other words, 144 is equal to 32k. So let's see what 144 divided by 32 is. That's 4.5. So k is equal to 4.5. All we do in the next step is put 4.5 in for k, nothing else. So y is equal to 4.5 times x times z squared. So here's our variation statement. And now we're going to be asked a question. Find y when x is 4 and z is, let me erase this so I can see, and z is 5. So where x, I'm going to replace that with 4, and with z, I'm going to replace it with 5. So y is equal to 4.5 times 4 times 5 squared, which is 25. And if you just take out a calculator and do that, y is going to be equal to 450. So here's an application of why you use direct variation, or when you would use variation. The distance s that an object falls varies directly as the square of time. Let's just write that down. Distance s varies directly as time squared. Next, we're going to be given information to allow us to solve for k. If an object falls 16 feet, so that's the distance, in 1 second, so t is 1, so k times 1 squared, which is just 1, how long will it take to fall 144 feet? So now I know that 16 is equal to k. So all I'm going to do is rewrite this formula using the number 16 for k. And now I'm going to fill in numbers to answer the question. How long will it take to fall 144 feet? So this 144 is the distance, s, and I'm trying to solve for how long. In other words, I'm trying to solve for t. So we'll divide both sides by 16. 144 over 16 equals t squared. We're going to take the square root, and that will give us 12/4, or in other words, 3. So it'll take 3 seconds for that to happen. One last example. The volume of a gas held at constant temperature varies inversely as the pressure. So let's just write that down. Volume varies inversely as pressure. Next, two numbers to help us solve for k. The volume is 1200 when the pressure is 200. So solving for k, that gives us this value for k. All we do is plug that into the original formula. V is equal to 240,000 over P. And now we'll be asked a question. Find the volume when the pressure is, and let's erase this so we can see, when the pressure is 300. So the volume is going to be 240,000 divided by 300. Or in other words, I think 800. Okay, and here's one for you to try. The current in a circuit varies inversely with its resistance. So let me help you get started. Current varies inversely. That means the next thing is going in the denominator as resistance. Solve for k, put it in the formula, answer the question, and you're all done.